Hello, welcome back. This is Jeff Byers, and I'm your instructor for NE255, and we are ready to move on to Module 2. Okay, so if you don't know this, I'm in Student View, so you can click on Show by Type. This will get everything organized like I want you to see it. So just click on Show by Type. I'm going to go ahead and leave Student View, and let's move on to creating a sparkler. Alright. So again, you guys can contact me at jbyers3@jcc.edu, and you can certainly contact me through Canvas, but I prefer jbyers3@jcc.edu. Alright, so I say each module will take 6 to 10 hours. These first 4 or 5 will not take that long unless you take a long time modeling and adding materials to objects. But that's really overly stated right here. So I would say probably 4 to 5 hours maybe for these. But I put 6 to 10 hours just to make sure you guys know that they do take some time, and they get a little more challenging as we move along. So Module 2, in this one you're going to create a particle system using an omni emitter. And you're going to add fields and collisions to the particles, and we kind of take you through the fields now. We're going to talk about fields. You're going to watch some tutorials. You don't have to do what they do unless you want to follow those. As far as actually creating, you can watch them and just kind of, because we're going to dive deeper into those. I just want to do an introduction to fields in this module. We're going to be using fields a lot more in a later module, so we'll be hitting it harder there in those other ones. And so objectives, you guys can read that. And below we have Module 2, lesson content, lectures, and video tutorials. And our discussion post assignment here is time management. Yes, you're rolling your eyes. I understand that you've probably done this before from me, but it's never too late to learn a little bit more about time management. Some of you are still struggling. In fact, most of the survey issues that I have are you wish you could do. You had better time management. So it's always good to discuss it. Maybe with your peers in the discussion forum. Maybe tell other peers what you've done and how are you successful. So make sure that you do some research and kind of give some ideas to other students and how you actually handle time management. That would be nice. Alright, so in Maya Fields, we're going to hit that lightly. This is just an introduction to Maya Fields. What are they? I think you get an idea that they can change the dynamics, and you can actually use particles and objects, fluid, soft bodies, and particles in cloth. And these fields will move those around and change the way they react to things. So I want you to go ahead and go through this, watch the video, and if you want to know a little bit more about the attributes, you can go into the attributes or air options. So we've got air first. You can just click on air options, and and it takes you right through to how the options or attributes actually work. Okay, so that's helpful. And as you go through those, just keep that in mind that we're not going to be using a lot of them now, but in the future we will. The ones I like the most are the volume axes and the volume curves. You can do a lot of cool things with those, and so you can read up on that a little bit. And then our course assignment again is I'm going to have you guys create a small room, a table, and a sparkler stick. There's not a whole lot we're going to have to model, and just follow those module assignments really closely. And then you're going to create an omni emitter, and of course we're going to show you how to change those attributes. And as you get more comfortable, we'll do more challenging things for you guys to do. It'll take a little bit longer, but hopefully you'll have a lot of fun doing it. And they're going to save your scene when your completed scene as an MB file, and then create a play blast, which is pretty easy to do. I've shown you how to do that already. If you need help with that, just go ahead and watch Module 1, turn in instructions on how to do that. But you should know how to do that. And I think I went through that here as well on the very last one. So you're going to turn in a compressed XVID or H.264 movie file, or AVI file if you're using Windows, and then zip it up and send it out to me. It's pretty simple, pretty straightforward. And since you've done Module 1, I feel like I don't need to really go through another instruction video, because that's kind of a you already know how to do it. Plus you can just read through the deliverables line for line, and you're good with that. And the simulation itself, it's worth 30 points, and then your scene that you created, the low poly scene that you created. Hopefully, feel free to use textures and add textures. Again, you only need to have diffuse maps or albedo maps. You don't need to worry about roughness maps or metallic maps or normal maps. Keep it pretty simple. But if you want to make it look a little more realistic, feel free to. And I encourage that. Above and beyond. And then we've got, how am I going to grade you? Of course, how realistic does your particle simulation look? Does it follow my instruction videos, tutorials, and example? Did you use an omni emitter? Did you add gravity? Did you add collisions to the table and floor? And did you create a particle collision event editor? I'll be looking for all that as I grade. Did you save out an MB file of your completed file? Did you create a play blast and compress it? And the total points you can earn is 40 points on that. And then we've got Module 2 course assignment, turn in instructions. Please make sure you follow the deliverables folder structure and instructions. Make sure you place all the required materials in the specified folders as instructed. Make sure your first and last name is on every file. Now, I already know, we already went through Module 1. I felt it was kind of redundant for me to continue making turn-in videos, which are really simple. You can see that we don't have much here as far as deliverables go. So we've got sparkler dynamic simulation. The student will turn in the completed sparkler simulation scene as an MB file format. Pretty simple. The student will turn in a play blast compressed with XVID or H.264 movie of the sparkler dynamic simulation. Again, you will turn in an AVI movie if you're using Windows, and just a movie file format if you're using Mac. If you have any questions or problems, just email me at jbyers3@jcc.edu. And folder structure is pretty simple, same as the first one, except we're going to put a 2 at the very end. And then you're going to create subfolders with scenes. Your scenes will go in here, your play blast will go in here, and you'll zip it up by using the same technique, basically right-clicking over an object and going into send to, and then compress the zipped folder. Okay. With that said, then congratulations, you're completely done. You can watch my example if you're not quite sure about something. If your file looks like it's too fast or too slow, you can kind of judge it by the example that I have here and the timing. Again, you can use any software that's available to you guys for post-production. Let's say you did all this work and you find out that your play blast is running too fast or running too slow. You can easily go into Premiere Pro and slow it down or speed it up. So if you need help with that or you have questions about that, let me know. I'll be happy to help you. Again, jbyers3@jcc.edu. I can't wait to hear from you guys and see your work. I hope you have a great week, and we'll see you guys in Module 3.